students, how are you all? I hope you all are fit and fine. So students, in the previous lecture we have done example number 3 and example number 4. Now comes to the exercise 1.2, question number 3. Show how root 5 can be represented on the number line. So for that, first of all we have to find out how we can find the root 5. Okay students, so when we take a base 2 units and a perpendicular 1 units, then using a Pythagoras theorem is only applicable for a 90 degrees angle. So by Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. Here we have to find out the hypotenuse. Okay, so perpendicular means 1, because here the perpendicular unit is 1, so we take the value of perpendicular 1, and base is 2 units. When we square 1, that is 1, and to square of 2 is 4, under root 1 plus 4, so we get under root 5. Now put this triangle on a number line. From 0 to 2 it is a base, and from this it is a perpendicular. And when we join a line, that is called hypotenuse, and here hypotenuse is root 5, so we put root 5 here. But we have to show the root 5 on the number line, so using a compass and taking a radius OA, we cut an arc on a number line, and that point we call D, and this point is called a root 5. So by this we can represent root 5 on the number line. Okay students, your homework is similarly example number 3 and example number 4. You have to do in your rough copy and send it tomorrow in the group. Okay students, now comes to the next topic, that is decimal expansion. Well, decimal expansions are of two types. The first one is terminating and the second one is non-terminating. Terminating means the remainder becomes 0. Terminating means the remainder becomes 0. For example, if we are taking a rational number 1 by 2 and its decimal expansion is 0.5, that means if we divide 1, 2, point, we get 0. Now 5 times, and here the remainder becomes 0. That means this type of expansion, this type of decimal expansion, we can say that this type of decimal expansion is terminating. And for non-terminating means the remainder never becomes 0. For example, 1 by 3 is equal to 0.333 and so on. And here for 1 by 7 is equal to 0.142857, it is goes on repeating. Okay, so here 1 by 3 is equal to 0.3333, so on. In this case 3 is repeating, so here we put bar on 3. That means 1 by 3 is equal to 0.3 bar, because we put here bar because 3 is repeating and so on. Okay, the bar indicates 3 is repeating and it never ends. So here we can say that 1 by 3 is non-terminating and repeating decimal expansion. So 1 by 3 is non-terminating and repeating decimal expansion because it goes on repeating 3 and so on. And it never becomes 0, its remainder never becomes 0, so therefore it is called non-terminating, and 3 is repeating in every time, so we use the word repeating here. So 1 by 3 is a non-terminating repeating decimal expansion. Now comes to the exercise 1.3 and question number 1. Our question number 1 is, write the following in decimal form and say what kind of decimal expansion each. We have to find out the decimal expansion, that it is either terminating or non-terminating. So first of all we have to divide it, we have to solve it. So 100 is equals to 360 point. We take here point because 36 is not divided by 100, so we take here We take here point and we get 0 here. So 100 3 times 300. 100 3 times we get 300, and after minus we get here 60. Now we get 0. Now 100 6 times 600. So here the remainder becomes 0. And when the remainder is 0, so 36 by 100 is terminating decimal expansion, because here the remainder is 0. So 36 by 100 is terminating decimal expansion. Now question number 2, that is 1 by 11. Again we have to divide it, and when we take a 100, when we take 1 and 11, so it can't be divided, so we take here 0 and take a point. Okay, now 11 is greater than 10, so again we put here 0 and take 0. Okay students, now look at here. 11 9 times 99. 11 9 times 99. So we put here 9, and after minus we get here remainder 1. Now again we are taking 1 0. Now 1 0, 10 is smaller than 11, so again we take here another 0, and for that 0 we put here 0. Okay, now again we have to minus it, subtract it, and then the remainder is 0. In this case the remainder never becomes 0. Again we get 1 1 1 1 1 and so on. So it is non-terminating and the answer is repeating. You can see here 0 9 0 9, and we are taking so on 0 9 0 9 0 9 0 9. Our answer is become repeating. So we can say that remainder never becomes 0. So it is non-terminating and repeating decimal expansion. So we put here 1 by 11 is equal to 0.09, and we put here bar because it is repeating. Okay students, now your homework is to do question number 1, all the remaining parts, that is question number 3rd, 4th, 5th and 6th. You have to solve this question in your rough copy and send it to the group tomorrow. Okay students, bye bye, have a nice day.